Hi guys, so today we are going to solve Leetcode problem number 295. Find the median from the data stream, right? So this is the problem that we are going to solve today. So what is asked in this question is we'll be getting a stream of integers as an input. Continuously we'll be getting the stream of data, and in the real time we have to find median. What median means is like the middle element of all the elements, right? So if we sort all the elements which are given us like 1 2 3 4 8 9, so this is the input that we have received so far. Similarly we'll be getting more, so but at this particular instant if we had to find the median, so it will be the middle element after sorting, right? So it will be, so in this case, since there are even number of elements present, so the middle elements are 2, so we have to find the average of both of them, so that will be 3 plus 4 by 2, that will be 3.5. So this is our median in this case. So this is how we basically find the median, but in the problem statement at any moment of time we will be asked to the median, so that's how we have to devise our solution. So now let's move to the problem. Okay, let us say these are the data, right? These are the data that we'll be getting as an input from the stream, right? So let's say the first element that we have received is 9. Okay, so let me write down what we'll be receiving in the from the stream, so it will be easy for us to understand. Okay, cool. So these are the elements that we'll be getting. So at this instance of time, right, t is equals to 1, let's say we are getting 9, right? So if someone asked us the median at this moment, t is equals to 1, so 9 will be the answer, right? Because this is the only thing present. So but the next element, let's say we have already processed 9 from stream, next element which we receive is 8. So how it will change for us, our evaluation will be like we have to arrange 8 in its correct position, so it will become 8 and 9. And now since there are two elements and it is in the sorted order, we have to find the median. Median will be the average of the middle elements. So in this case there are two middle elements, so it will be 8 plus 9 by 2. So this value will be 8.5. This is our answer median. Now next element that we'll be receiving is 4. So it will be 4 8 9. The 4 is inserted at its correct position here. So in this case if we look at the middle element, right, so in this case the median is 8, so 8 will be our answer. Next process, the element that we have to process is 2. Okay, so 2 will be again, its correct position will be at the beginning, so 2 4 8 and 9. Now if we have to find the median, so it will be the average of the middle element, so that will be 4 plus 8 by 2, that is 6. Now next element that we have to process is 3, so the correct position of 3 will be 2 3, right, then 4 8 and 9. Since there are odd number of elements this time, so the median will be 4, right? So this is the middle element 4, so the median is 4. The next element that we have to process from the stream is 1, right? So 1 will come in the beginning, 1 2 3 4 8 9, right? So now in this case the median will be the average of the middle element, that is 3 and 4, that will be 3 plus 4 by 2, that is 3.5. So this is our answer. So now let's try to observe what is the pattern that we are seeing. So with each element of the stream that we are getting, right, so we are trying to insert it at its correct position, right? That's what we are trying to do. In this case we have received 8, so we have inserted its correct position. Then we have received 4, then we have received 2, then we have received 3, then we have received 1. With each element we are trying to insert it at its correct position such that the final resultant array should remain sorted. Once we are able to achieve that, what we are doing is we are finding the middle element, right? So once our array is sorted, right, what we are trying to do is find the middle element. Now there are two cases while finding the middle element, right? One, when there are odd number of elements, right, and second is when there are even number of elements, right? So in case of odd, there will be one middle element, right? So that's what we are returning. As we can see here, 8 is the middle element and total number of elements are odd, so we have returned 8. But in case of even, like in the last case 3 and 4, there will be two middle elements. So we have to find the average in that case, average of middle elements. That's what we have to find. So let's try to see which data structure we can use here. So if you look at the last case, right, this one, here if you observe what we are doing, we are evaluating on the middle elements, right? So if we divide this array into two parts, right, like this, so there will be a left half and then there is a right half, right? So if you see the average of these two elements that we are finding, right, we are finding the average of these two elements. So what are these two elements? So from the left hand side, right, this is the maximum element. 3 is the maximum element, right? While from the right hand side, 4 is the minimum element, right? 4 is equals to minimum element from all the elements on the right hand side, right? While 3 is the maximum element from all the elements on the left hand side. Now, somehow, if we are able to store all the elements on the right hand side to some data structure and of the left hand side into another data structure, right? And this data structure should be able to give us the maximum from the left hand side of all the elements, and from the right hand side this data structure should give us the minimum of all the elements. Okay, so if we have here 1 comma 2 comma 3, so in this case it should return 3. And if we are on the right side, we have 4, 8, 9. So in this case, it should return us the minimum, right? So that's what we are doing. But this will be the case when we are having even number of elements. But what about odd number of elements? So in case of odd elements, let's try to put the middle element on either of the one side, right? Either on the left hand side or on the right hand side. So let's, in this case, I'll go with the left hand side. So if we do the partitioning in case of we are having odd number of element and we try to take the middle element in the left hand side partition, so it will be something like this, right? Okay, so that's how we'll be doing the partitioning. And in the above case here we have even number, so it will partitioning will be like this. And here we have odd, so we have partitioning like this. Here we have even, so partitioning will be like this. Here we have odd, so partitioning will be like this, right? So if you observe, what we are seeing is in case of even, right, there are equal number of elements on both the left hand side as well as right hand side. But in case of odd, there are more number of elements on left hand side, right? So here are 3, here are 2. In case of even, there are equal to 2. But in case of odd, here are 2, here is 1. In this case also even, so 1 and 1 are equal. But in this case, this side 0, this side 1. So anywhere at any instance of time, you will see that the size of the right hand side is never greater than the left hand side. It can be equal, right? RHS size can be equal to LHS, but it's never greater. This case is never going to happen, right? So we have to keep that in mind. So by now you must have guessed which data structure we are going to use, and you are correct. We are going to use heap data structure, right? So for this case, we'll be creating a max heap, and for this one, we'll be creating a min heap, because here we want to get the maximum element and here we want to get the minimum element of all the elements, right? So this will be our max heap, right? And this will be our min heap. Now with this, there is one challenge, right? How we'll be maintaining that we always stay at the middle of all the elements, right? So as you must have noticed, like these, if these are all the elements, okay, let me draw it once again here. So like if 1, 2, 3, 4, 8, 9, right? So these are the elements so far we have received from the string. How we'll be able to be at the middle with the help of these two heaps? To understand that, let's go a little back. to see how we were processing the elements. So here, if you can notice on the right hand side, we are never getting the value greater than the left hand side. So here, if you can notice, like it's 0 and 1, 1 and 1, we are definitely getting equal values, but never on the right hand side the value is greater than what it is on the left hand side. Basically, what is happening that we have to notice. So to deep diving, let's take this use case 2489. Okay, so here we have 2, right? Here we have 4, here we have 8, and here we have 9. So now what will happen, like let's say another element like 10 comes into picture, right? Now as we know, like this is the value is 10, right? So ideally how we should do it, so it's like it will be 2, 4, 8, 9 and 10, right? Without considering the heap, if we have to simply do it, how we will find the median. So we will sort it all the elements and then we will find the middle element. Since there are odd number of elements, so the middle one would be the median. So in this case it will be 8. But how we can be so sure, right, that it will be go to the main heap like this one? Just by looking at the our doing it manually and checking, we know that it will go to the main heap. But how we can be so sure without passing it through max heap? Because it may be the case, there is another case. Let's say one comes into picture, right? Now one is a new element. If that is the case, then our final array would look something like this: 1, 2, 4, 8, 9. In this case, our median would be 4, right? So if 1 comes, then it will be residing in the max heap, but if 10 comes, it will be residing in the main heap. Basically, from this, what we understood is like whatsoever the element comes, we have to put it through the max heap first. You put this 10 here first, so it will be something like this. But we checked here, correct position of 10 is on the min heap and that at the extreme right. What we have to do, we have to pop this from here and put it to the min heap. So this will remove from here and its final location will be here in the min heap. But this will violate our condition. What was the condition? That is, size of RHS can never be greater than LHS. So in this case, what we have to do, we have to pop one element from here and put it back to the max heap. So the minimum value out of these three is 8 and we have to put it back into the max heap like this. Okay. So let's iterate it once again with 1. What will happen if this is the state of our heaps and if 1 comes into picture, what will happen? So the moment 1 will come, we will put it in our max heap. So 1 will go here. Meanwhile, what we will do, let's try to do it manually. What will be the state? So it will be 1, 2, 4, 8, 9 and 10. So there are even number of elements here, right? So we will take the middle two and find their average. So 8 plus 4 by 2, it is 6. So this should be our answer. So what we have to do, the moment we put 1 here in the max heap, we have to then pop one element from our max heap, the max value. So it's 8, we popped it, we put it in our min heap, which is here, right? So it's 8, 9, 10 now. Then what we did, we checked whether the size of min heap is it greater than max heap. So it is not. So this condition is fine, right? So there is no need to pop any element from the min heap and put it back to the max heap like we did in the case of 10. So what will be the final state? 8 is in the min heap. Now we have removed it from the max. So this is the final state. And if we want to find median here, we will pop one element, max element from here, that is 4. And from min heap, we will pop minimum element, that is 8. We will do the average and it will be equal to 6. Hence we verified whatever value we are getting from heaps is same as that what we have evaluated manually. So in both cases we are getting the 6 as the median. So just to summarize both the use case, what we discussed in case of 10 as well as in 1 when we put it in our heaps. So what are the steps that we followed? So the first step was like we put element to max heap, right? Then pop element from max heap. Then put that popped element to main heap, right? And if the size of main heap becomes greater than max heap, right? Then what we do, then we pop from main heap and put to max heap, right? So these are the steps that we followed. Now let's move to the coding section. As we have discussed all of this, the coding is going to be pretty straightforward. So in the problem statement on the Leetcode, we have been given a class which contains three functions. So the first one is median finder, right? So this is the first function. In this, we don't have to do anything. We just have to initialize our priority queue, right? So priority queue, since for this one, I'll be using Java, right? And in Java, for the implementation of heaps, we use priority queue. So I'll be using that to create both min as well as max heap. Okay. So basically at class level, I will declare my two queues for priority queue, right? One will be my min heap and another queue that will be my max heap, right? And our first function, that is median finder, in this one basically I'll just initialize both of them. So this is our first function. For our second function that's given to us is public void add num. So with each incoming element of the stream, we'll be using this function to add. As we discussed, there are these these four steps that we have to follow step by step. So while we are adding number to our heaps, right? So the first step is, so the first step was to add to the max heap. So what we will do, we will add it to the max heap, that is max dot add num. Once we have added that element, next we have to do is we have to take out the maximum element from the max heap. So int high will be equal to max dot poll. Okay. Then what we have to do, we have to put that in the min heap. So min dot high. Okay, so now we have added it. But if there may be a case if the size of min heap becomes greater than that of max heap. So if min dot size is greater than max dot size, right? In that case, what we have to do, we have to take out the smallest element from the min heap. and we have to put it back to the max heap. That's it. So this is our addnum function. Now the third function which they have given us is actually the one which is used to find the median at any instant of time. So that's public double find median. So basically we will have to use this function to return the median. To do that, this function has to handle two cases, that is when there are odd number of elements and when there are even number of elements. So let's go with the odd one first. So let's say we have 1 2 3 4 and 5, right? In this case the max heap, that is on the LHS size, will be greater than what we have on the RHS, that is min heap, right? So if this is the case, to get the median, what we have to do, we have to pick the element from the max heap, right? So if max dot size is greater than min dot size, right? Then what we have to do, I'm using ternary operator here. In that case, what we have to do, we have to do max dot peak. Okay. Otherwise, the second case is when there are even number of elements, right? So let's say we have 6 here. Then in that case, we have to find the average of the middle element, that is 3 and 4. So what we will do, we will find the average of both of them, that is min dot peak plus max dot peak, right? Multiply by 0.5, that is, or you can write divide by 2. So yeah, this will give us our final answer. So do subscribe to this channel for more upcoming content like this.